In this video, we are going to be exploring how you can represent ratios and proportional relationships using a variety of diagrams and strategies. So we're going to present you with 4 different strategies that you can use, and you're free to use any of them whichever way it clicks for you and makes sense to solve problems with ratios. Okay, so for this problem, for every 3 boys in class, there are 5 girls. If there are 12 boys, how many students are girls? So our ratio is 3 to 5, and we know that there are 12 boys total. So we need to then use that information to figure out how many girls there are in the class. So the first strategy we are going to look at is tape diagram. Okay, so it's called a tape diagram because it looks like you're drawing like a strip of tape with like little segments, and then diagram because it's, a picture. Okay, so we're going to take the 2 things that they give us, so boys to girls, and we're going to label it here and here. Now this also works really, really well in your math journal using the graph paper, where you just use the little grid boxes that are drawn there for you. So each little one you can draw like a perimeter around the whole thing, and then those little segments will be there for you. So this is a really easy one to use in your journal. Okay, so I know the ratio is 3 to 5. So I'm going to take boys and I'm going to draw those 3 little squares. And for girls, I'm going to draw 5 little squares because the ratio is 3 to 5. All right, now of those 3 squares, we know that there are 12 boys in all. So if there are 12 boys in all, then I need to evenly distribute that 12 amongst those 3 little boxes. So that means that I would have 4 and 4 and 4. So I'm just taking 12, dividing it by 3, and I have 4, 4, 4. Okay, so if this is in the same ratio, the 3 to 5, then I can transfer that number, that 4, into these boxes. I can say, okay, well, if we are going to have a proportional relationship here, each one of these boxes must also be 4, 4, 4, and 4. So 4 girls, 4 girls, 4, 4. So how many girls are there total? So 4, 8, 12, 16, and 20. So I know that there are going to be 20 students. Okay, so another strategy that you can use is you can use a double number line. Okay, so double number line, you're just drawing the one number line this way and creating vertical little hashes where one side represents one part of your ratio and then the other side represents the other one. So then you're going to label it there. Again, this works really great in your math journal, so drawing it accordingly. So if the ratio is 3 to 5, and we know it's proportional, you always start with 0, 0 on your line. Then you are going to put for the first little hash, or the first notch after the zeros, the 3 to 5. And now you are just going to increase each side by the amount that it was here. So from 0 to 3, I am increasing by 3. So it would be 3, 6, 9, 12, and you could keep going depending on what your numbers are. And then on this side of my number line, I am going to increase it by the difference between 0 to 5. So 5, and then 10, 15, and 20, and I could keep going if I needed to. Now the information they give me is if there are 12 boys, so here it is, how many are girls? So I look to the number that's across, there it is, 20. So I basically just am creating a list of equivalent ratios till I get to the number that we're looking for. All right, so the next strategy is you can use a ratio table. Okay, so a ratio table actually looks very similar to your double number line, but you're setting it up this way. I've also seen it where your ratio tables are vertical. That's fine too. Okay, so in our ratio table, we're just going to start with for every 3 boys, there are 5 girls. And then you keep increasing by those values until you get to the one that you want. So 3, I'm going to then go to the next set, 3, and then 6. So I'm going to double it. 5 doubled, that's going to be 10. All right, now I'm going to triple it. So 3 times 3, that's going to be 9. 5 times 3, that's going to be 15. Now I'm going to go to the next one. I'm going to do times 4. So increasing by a scale factor of 4. 3 times 4, that's going to be 12. 5 times 4, that's going to be 20. So I now have this set of equivalent ratios in a table. You also can then skip really, really big. You can just go 3, let's say I want to see what the equivalent ratio is that's 10 times bigger. 3 times 10 would be 30. 5 times 10, that would be 50. So that might be an equivalent ratio. All right, and then the last method is that you can use an equation to set it up. Okay, so you're going to set it up algebraically where you use the format like a fraction. So you'd put your ratio of 3 to 5 in fractional form, and that's equivalent to, and then the fractional value that you know, so they give you the 12. So the boys are the numerators, so that remains, that's what you know. And then the girls are your denominators, and this is what you don't know. So that's where your x is, or your variable, your unknown. And we can use our methods and strategies to solve for x. Okay, so using our proportional reasoning and thinking, we know that we are just finding an equivalent ratio. So you figure, what is the scale factor that you're multiplying by? To get from 3 to 12, you're increasing it by a scale factor of 4, or times 4. So what you do to the numerator, you need to do to the denominator, so times 4. So 5 times 4 is going to be 20, so therefore x is 20. You also, there's another way that you can solve this here, where if you recall, when you're trying to remove a denominator algebraically, right, this is being divided by that. So in order to undo divide, you do the operational opposite, which means multiply. So you're going to multiply that side by x, multiply that side by 5, and you end up having something that looks like this. 3x equals 12 times 5. So you've multiplied this by that and this by that. And now you simplify. 3x equals 60. And then I'm going to divide each side by 3, divide each side by 3, and x equals 20. Okay, so there we go. Those are our 4 strategies for representing ratios and proportional relationships to solve ratio problems. Tape diagram, double number line, ratio table, and an equation where you can solve it 2 different ways, using algebraic notation or thinking of it as an equivalent fraction. All right, that's it.